good. How are you? Good. Okay, we've still got some of this third page of systems of equations that we need to cover. And then after that, I have a pretty good idea that we should probably go to factoring. Factoring is something you absolutely have to know how to do for the next 4 years, and that's a broad subject. That'll take us a few hours to cover factoring. However, I'm a little concerned. I would like to kind of stick to your book. I noticed that this last page that I took a picture of is 142. Is that correct?
Yeah, that's correct. Yeah.
In terms of working on the problems that they told you to work on this summer out of your book, what have you done everything prior to this, or was this just did you randomly pull these 3 pages out?
He the pages out for me, and then he told us to do this.
Okay, so we definitely need to do this. My question is, after this, what next part of the book should you be working on?
I'm not really sure.
Okay,
Yeah.
well, we'll just play it by ear then, and I think what we'll do is factoring. Factoring, like I said, you need to know how to factor. But let's finish up these. Let's start with 1B and 1C. Hold on a little bit. Let me get my stuff in place here. All right. What am I going to do with 1B? Got 1/2 x plus y equals 6. And we got 1/2 x minus y equals 2.
Alright. So I think that we should add the 2 equations, because then the y's will cancel, and then the 2 1/2 will become a 1 whole.
Okay, so what's the bottom below the line here, Reed?
1x equals 9.
8.
Yeah, sorry.
Remember, when you're adding 2 even numbers, you're always going to get an even number. Little rules like that can help you from making small mistakes like that. If I'm adding an even number to an odd number, I'm always getting an odd number. If I'm adding 2 odds, I'm always getting an even number. So, okay, let's look at 1C. It's weird how their book won't print out the negative sign in the right place. Okay, what can we do here? How can we eliminate a variable?
Multiply the top by 2.
Good. So what is the new equation number 1 going to be? What's that?
6/4x.
Okay, reduce 6/4. Whenever you have an even number over an even number, you can always reduce it, because you can always divide top and bottom by 2. So what's 6/4 equal to?
going since we're being blank right now.
6 over 4, divide top and bottom by 2, what do you get?
Oh. 2.
You get 3 halves. In other words, if I divide the top by 6, I get 3. If I divide the top by 2, I get 3. And if I divide the bottom by 2, I get 2. So this becomes 3 over 2. So the new equation is 3 over 2x. What's the rest of it?
Plus 2y.
Equals what?
12.
Okay. And so we'll draw a temporary line through that one. And now we're dealing with equations 1 and 2. And now what's the best way to eliminate a variable?
We
add the two equations. What do you get? What's 1/2 x plus 3/2 x?
4 over 2, which is 1/2 x.
Well, hold on. You're right. It's 4 over 2, but that's not 1/2. 4 over 2 is 2. So this ends up being 2x when we add. In other words, think of this, well, you did it. You had 1/2, you're adding to 3/2. It's common denominator, so you can just add the numerators, you get 4/2. But you always got to simplify it. And then what's the rest of it?
Equals 8.
So x equals 4. And then you go back into the simplest equation and solve for y. What is the simplest equation that we would pick in order to solve for y? And we can use any of these 3. In other words, this is the same equation as this, but in terms of solving for y, it's not the same. It's going to be harder to solve for y if we use this one. You always want to go back to the simplest one, but you got a choice of 1 or 2. Remember, x is equal to 4. Which one would you choose?
The first one.
Yeah, notice y. And I don't mean the letter y. I mean, when I substitute x for 4, this operation is going to be very nice, right? What is that going to be? What's 3/4 times 4? 3/4 times x, which is, we now know is 4, plus y equals 6. Well, what's that? Simplify. Always look to simplify.
I multiply the top by 4 and the bottom by 4?
Divide the top by 4 and the bottom by 4. In other words, this 4 over this 4 can be, some people say you can cancel them, but you're really not canceling them. You're leaving behind a 1. But that's fine, because now we know that that's equal to 3. So now we have 3 plus y equals 6. So solving for y is going to be really simple. Doesn't even involve any negative numbers. Whereas had we used this equation and substituted for x, we would have been left with that minus 2y over there. We would have a negative number over there. Just better to avoid negative numbers. All right. Let's go and look at this. I think you're pretty good, pretty strong with this elimination. Where you may have some weaknesses is in the fractions, just like you said. So let's make sure we cover these. I didn't know whether we necessarily needed to cover these problems today, but I think we do. Now they're kind of lobbing you up a softball here. What's the next line? Well, first of all, tell me whether you're going to add or subtract the equations, And then give me the next line.
I think we're going to add these equations.
Okay.
And then it would be 5 over 5. X would be just 1 plus, or equals 10.
Now, which one should we plug into to solve for y?
The top one.
Yeah, because again, that plus y is going to make it easier than this negative y. Okay, so plug in x equals 10 and solve that one. What can I do? What's this equal to? What'd you say?
So I think we, like 5 goes into 10 twice, so like.
Yes, that's what you want to do. In other words, when you're looking to simplify this, when I'm looking to simplify that, I'm looking for anything that divides into top and bottom evenly. 3 doesn't, but 5 does. 5 goes into the bottom exactly once, and it goes into the top exactly twice. So I can put a line through that, and put a line through that, and replace it with a 2. Now it's much easier. Now it's what? Yeah, 6 plus y equals 11. One more step, y equals 5. All right. Let's hope they make it a little harder and moderately. What am I going to do to these two equations?
Sorry, John. I think we're going to substitute.
Good. What do we get when we add them?
It's 4 over 3x.
You get what? 4 over 3x, okay.
Yeah, and then equals 8.
Okay, now what? You can do this last step in either 1 step or 2 steps. If you were doing it in 2 steps, what would your first step be?
Simplify the fraction?
Can't simplify it. 4/3 is as simple. There's no number that divides into both 4 and 3. So that's as simplified as I can get. But if I'm just trying to solve this equation, if I give you that equation to solve for x, what's your first step? Get rid of denominators. Notice that if I get rid of the 3, I'm not going to have any fractions anymore. So it's easier if you don't work with fractions, right?
Yeah.
So let's make our first step, multiply both sides by 3. What do you get?
Multiply both sides by 3?
I'm going to multiply that side by 3. I'm going to multiply this side by 3.
Alright, so it's going to be... So we don't change anything with the 4, we only change the 3, right?
Yeah, in other words, this 3 cancels with that 3. So we're left with just 4x. In other words, whenever you're multiplying by the denominator, you're doing it to get rid of it. So you always know that it's going to disappear. Now what's the next step?
The x equals 6.
Correct. In other words, the next step is to divide both sides by 4. Okay, so what we did here, notice, was that we multiplied by the denominator and we divided by the numerator. So I could do that in one step. Just multiply everything by the reciprocal of this number. Okay? Now, we're guaranteed that this number disappears when you multiply by the reciprocal. Well, that 3 cancels with that, and that 4 cancels with that. So we're left with x. Now, what would be our step on the right side? How would we simplify that before multiplying it out?
Multiplying everything inside there, like 8 times.
Well, you could do it the hard way. Multiply 8 times 3, which is 24, divided by 4. In other words, this is another case where there's a 1 under that 8. So you're just multiplying numerators and multiplying denominators. That's the way you multiply numbers, fractions or otherwise. However, why deal with a number as big as 24? Because then you're going to have to divide that big number by 4. Let's simplify this first. How can I simplify this? Divide top and bottom by what?
By 4.
Yeah. That changes that to a 1 and that to a 2. And now we just have to multiply 2 times 3 to get our 6. Notice the biggest number we dealt with was an 8. So this simplification process is really an important process. It's no different than if I told you, what's that equal to? Yeah, the x's cancel, the y's cancel, and the only thing I have left with is a z in the numerator. If that z had been in the denominator instead, like that, then my answer would be 1 over z. So what's this equal to? Simplify first.
42 over 7.
Don't do it that way. When you do it that way, you bring in a big number, 42, into the problem that doesn't need to be in there. What is this?
That is 2.
Yeah. So the problem is 2 times 3. That's the problem, is 2 times 3. And the way this is 2 is I'm dividing the bottom by 7, leaving behind a 1. I'm dividing the top by 7, leaving behind a 2. This is why these one-digit calculations are so important. Because otherwise, you would do this on a calculator. You'd do it the hard way. You'd just multiply 14 times 3 and divide by 7. But I'm trying to get you away from that dependence on the calculator. And there's a really good reason why. Is because you're going to end up looking at math that you can't do on calculators. When you factor a number, it's really hard to do it on a calculator. You need to know your multiplication tables and your division tables. So, let's see. Is there one more here? No, that's it. All right. Oh, no, there is one more. Okay, a little harder. What do you notice right off the get-go when you look at this problem?
That I could multiply the top by 3.
Well, when I said, what do you notice? What you should have noticed was that that is the same as that. So what can I do to eliminate a variable immediately? I don't have to do any multiplication first. The audio is giving us a little problems here, I think. You still there?
Yeah.
So what can I do? Since this is the same as this, how can I eliminate x?
We subtract.
Okay, let's put a big minus sign right there. Okay, that gets rid of the fraction immediately, which is good. Now what goes here? What is 1y minus a negative 3y? This is exactly the same problem as this.
Negative 2y.
What is 1 minus a negative 3?
4.
Okay. In other words, you change all your subtraction. Here's the subtraction sign. So you want to change it to a positive sign. But if you do that, you have to change the sign of what was being subtracted. So now we have 1 plus 3. So this becomes 4y. In other words, it's fine that we can do this problem by subtracting. The problem, you'll notice, would have been significantly harder had we done what you wanted to do. We can do it that way. Let's just look at what the difference is. And sometimes why you should subtract and not add is because it's so much easier. If I multiply the top by 3, okay, well, what do I get? I get 9/4 x plus 3y equals 33. Okay, so that's my new equation. Now, I want to add these two equations to get rid of the y. Doesn't matter which variable you eliminate first. You're going to solve for the other variable, and then you're going to go back and solve for the second variable. So, which one doesn't matter. It's a question of how hard it is to do. Well, if I have to add these two, I'm going to get rid of the y, but now I got to add that fraction to that fraction, which isn't that hard. It's 12/4, which is 3x equals, and now I got more big numbers that I didn't really need to have. So I can solve for x equal 12, but I would rather not work with fractions. And the way to not work with fractions here is to subtract the two equations, not to add them. But you don't want to do that unless you're 100% confident in your subtraction ability. In other words, that gave you a little trouble subtracting those two equations. Always remember that when you're subtracting these two equations and you get to this part, that's the same as 1y minus a negative 3y. All right. Let's talk about factoring. I only got 5 minutes, but there's 3 main kinds of factoring. The kind that's the easiest is greatest common factor. Okay? If I give you these two numbers, what's the greatest common factor that can be taken out? I'll put a variable in here so as to not to confuse things. 6x plus 8. What's the greatest common factor? When I say greatest common factor, I mean what is the biggest quantity that divides into both entities evenly?
24.
Does 24 divide into 8 evenly? You're going the wrong way. We need to be able to take our greatest common factor and divide it into each of these terms and come up with a whole number. 6 work?
Yeah.
6 goes into this one, but it doesn't go into this one.
Oh.
4 work?
4 doesn't go into 6.
Okay, let's keep going down because we know we're going to need an even number. 2.
Yeah,
Does 2 work?
2.
2 does work. So I'll factor out the 2. And then what's left behind is whatever you get when you divide that term by 2. Well, you get 3x plus 4. So I have taken a greatest common factor out of that original expression. And that's all greatest common factor is. Let me give you a few more. What's the greatest common factor? 5x. You see why I can take an x out also? Because both terms have an x in them. So I can divide that term by 5x, and I'm left with just x. And I can divide this term by 5x, and I'm left with 2. So when you're searching for greatest common factor, it means exactly what it says. You need to find the greatest number. 5 is a factor, but it wasn't the greatest common factor. The greatest common factor is 5 and x. If I do one other thing, now what's the greatest common factor?
Now it's just 5?
Now it's just 5, exactly. Because I can't divide this last term by x. So now it's 5 times x squared plus 2x plus 1. And it's really important when you're doing this greatest common factor that as you do it, that in your head, you're multiplying that back together again to make sure you got that. And when I multiply that times that, I got to make sure I got that. And when I multiply that by that, I got to make sure I got that last number 5. Okay? So the biggest thing you never want to do is factor a greatest common factor out and then have it not multiply back together again. That's a silly error because it's never necessary. In other words, you can always do this check. And you kind of almost should do it one term at a time. In other words, the first thing I realize is I get x squared. Well, is 5 times x squared 5x squared? Yes. Okay, I did the first term right. Second term, I think it's 2. 5 times 2 is not 10x. It's not 2. But if I add an x, now it is. Same thing at the end. 5 times 1 is 5. Good place to end. Next time we'll pick up with more greatest common factors and factoring quadratics. Is that in your book? Can you, between now and our next session, see if you can find somewhere in your book that talks about factoring quadratics. I know you're going to get there during school next year, so anything that we work on is never going to be wasted. But I'd rather do it in order of what they're going to expect you to know.
Yeah.
You know? So, Chris, I will talk to you next time.
Oh, and my grandma wanted to know where to mail the check.
Okay, let me write it right here. Make it to me. And this is my address. Quarry Mountain. It's not a street, it's just Quarry Mountain. And Littleton 80127. Can you read all that?
Yeah.
Okay.
All right. Thank you.
You're welcome.
I got. Yeah.
Talk to you Friday.